Well, hi, good morning. Thanks so much for joining me here in my shop. Today is September 3rd. So just before I get going on the radio here, and what I'm going to be doing, by the way, is I'm going to be checking the alignment of this radio and adjusting it. Just the IF alignment. That's what I hope to do today. But before I do that, I'm going to let you in on what it's like to be a video maker when it comes to advertising and the like. The advertisements you see on my videos are put there by YouTube and Google and that, and they have nothing to do with me directly. But like lots of video makers, I'm sure lots of them, I get emails almost daily asking me to promote products on my little channel here. Now, I don't have a lot of viewers. This is very much a specialty channel, so people like you watching this are kind of a little bit special, I would say. So I don't have a huge viewership like some other channels. Nevertheless, almost every day I am getting offers of various sorts. Now, it used to be, from a company like supplying products. They would say, we'll send you some of our products if you'll show them and promote them on your channel, or you can keep the products. And in some cases, that could be something valuable. That could be something worth 50, 100 bucks easily. It means nothing to a manufacturer to send out a $50 device to someone like me. But if you notice, you haven't seen much of that on my channel. There's actually been a little bit a year or two ago, but none since then. But here's what's happened recently. Recently, I've been getting emails just literally offering me cash if I'll take their advertisement, which they will send to me, their video advertisement, and stick it in my video. They will offer me cash. They ask, how much money do you want to put this video advertisement in your video? Now, I'm not doing this. I thought hard about it, and I've decided I'm not doing this. I'm not going to get involved with this kind of stuff. It changes the nature of everything I'm doing. My relationship with you, a viewer, everything changes. So I'm not doing that. I'm going to resist it. But you'll see lots of video makers popping up products, popping up advertisements in the middle of their videos. They're cashing out. You know what happens? You build a relationship with a supplier. You want to continue that relationship. You stop telling the truth. Now I'm going to tell some truth. I'm doing this. I'm doing this for you. Okay, see this product here? I am not being promoted in any way to promote this product. This company that makes this stuff, this is hand soap, they have no idea I'm doing this. I'm not about to tell them. They're not sending me any money. My wife bought this product, but I'm telling you, this is so good. I've got it on my video here. I'm telling you, this is great hand soap. This is, I've been around for a while. I've washed my hands with lots of soap. This is head and shoulders above anything else I've ever used. I don't know what it is about it, but it's fantastic. Cleans your hands like you wouldn't believe. It's really wonderful. So, Rocky Mountain Soap Company Antibacterial Kitchen Hand Wash. Now, these guys are located in Canada. They're out in British Columbia, so you'd have to get them to mail this out to you, I guess. I don't really know. My wife bought it, so I don't really know how she got it. I think she must have got it off their website or something like that. But I'm telling you, there's nothing like this stuff. I've used, Fast Orange, all that stuff. This stuff's great. Anyway, there you go. Now, that's a real promotion in which I'm doing this to try to help you as a viewer to get a decent product. I'm not getting anything out of this except the product itself, which we bought. Okay, there you go. That's a real product promotion. I'm really, quite honestly, that's great stuff. Okay, now that company will get a rush from the 12 of you, a rush order. Okay, so I'm going to stop for a minute. I got soap on my fingers here. I have to wash my hands. So the reason I think I can align it makes sense to try to align this is the end of the video, or yesterday's video. It seemed pretty clear that the alignment was off by about 200 kilohertz. So I'm going to try to align it now, but I'm going to start with just a single frequency signal generator, just a single 10.7 kilohertz, megahertz actually, megahertz signal going in there, and then I'm going to use my alignment tool and touch up the transformers and see if, in fact, it's true what I thought at the radio's weight of alignment. This is where I think the IF is sitting right now, 10.5 instead of 10.7. Okay, we'll flip on the radio here. Now, in order to do this, since I'm not using a sweep, I'm just going to use a single frequency. This isn't even switched on. It's not part of the picture right now. The signal we're using is coming out of this guy. And he's coming around. Where? Where is he? He's coming around and going nowhere yet. Okay, so I'm going to feed this. Now, yesterday I determined where there was a where I could input an IF signal, like a 10.7 signal, and it's basically the output of the FM receiver. The box is just on the other side here, down in here. The clip lead's on it. So if I feed in the signal from this signal generator at 10.7, it should go through and produce a voltage at this test point right here. And then I've got a voltmeter connected. There's the clip connected with this white clip lead. The scope is connected, but I don't even have it switched on. Down comes the wire over to the voltmeter here, out of sight for you. I'm going to turn this way. This should show you all the action. Hey, why don't we turn the scope on anyway for fun? I don't think there's going to be anything interesting on it. Because the sweep generator is not operating, but we'll just have that on there anyway. There we are, something more to look at. Okay, so we're going to input the signal. I'm going to check the signal levels very high right now. I'm going to reach in front of the camera here. Put the signal very low, coming out of the signal generator. Put that like that. Now, we're still tuned. You can't see that, can you? Can't quite see the frequency setting, but the frequency setting won't be changing once we get going. It's 10.5 right now. Like I said, it's where I think the IF is tuned, but I was using this sweep instrument. It's all new stuff. I could be totally wrong. So we're now going to hook up this. Don't see any response anywhere. Oh, that's right. I shouldn't expect to see a response, should I? Well, I don't know. Didn't hear anything. Why don't we take this one off? So this was the coming from this other signal generator, which we're not using. I'll just take it right off. Put this on. You can hear something now coming out of that speaker. I didn't have it turned up. So we're putting in a low level 10.5 into the IF. It's unmodulated. It needs to be, oh geez, if we modulate it, it'll modulate with AM. And that may not appear in the output. Let's try it anyway. Okay, so that's a 30% modulation at 400 Hertz. It may come through a little bit. A really good FM radio, no. So I don't hear anything now. On the meter over yonder, we see nothing also. The meter set 1.5 volts. There's nothing there. We're off to a bad start. So I'm going to vary the frequency on the signal generator. And see what happens on that meter there. I'll just call out the numbers here. 10.5, 10.6, 10.7, nothing at all. What is wrong? Look, it's an extremely low level of signal coming out of my signal generator, so let me bump it up. Right now it's at 10.8. So we'll go up, up. Oh, I hear it and I see it, and I see it on the scope even. So, negative voltage coming up. There we are. Now, we're hearing it at 10.8. Now you can keep your eye on the scope actually. Now the scope is set to DC, so that the scope will go up and down like this, representing the strength of the signal that is being demodulated. at the output of the IF. Okay, here we go. Going down in frequency here. Oh, you can see it all. Okay, I'm just going to knock back the signal generator. Oop, not that far. Okay, keep going. Oh, we're already at 10.6. So you can kind of just watch the scope and you can figure out where the peak is. So I'm not even looking at the numbers there. I would say that's where it's tuned. 10 point, just under 7. So now we got to wonder what the heck's going on here, that when I do this alignment thing with a single frequency, I get what you should get, 10.7. When I did it with the sweeper, it sure looked like 200 kilohertz off. That's one of the reasons why I wanted to do this right away today. This single frequency thing is simple. I've done it so many times. I feel very reassured when I do it. So that also means if the IF is tuned properly, and we don't really know that yet, to 10.7, it's not the reason why the receiver is weak. Well, that's a bit of a disappointment. So what I'm going to do, I'm going to set this to 10.7. Let's watch the, it's hardly a change, is it? And the bandwidth is fairly wide on a FM receiver, so probably you can move that around a fair bit and not see variations in the output. Which is rated nothing here. There's nothing here for me to see. Why is it so low here? Well, scope's on ×1. It's taking a little bit of energy out, and if I take it to 10 times 10, it'll draw less energy. You'll see the meter go up a wee bit. But wow, that's pretty hard to work with. How come it's so tiny? Well, you know, the same DC voltage is occurring here. And we'll make this as sensitive as possible. See if I can use it. So I'll vary the. Maybe we just need more signal. What happened to the scope? Scope is on ×10, ×1. They get a good look at the DC on the scope. Yeah, you know what? It's good on the scope. So what we're going to do, I'm going to lower the trace down there. I'm going to change the frequency over here. So that's a strange effect, isn't it? The sound didn't, the volume of the sound didn't seem to follow directly the strength of that signal. Okay, so that's maximum signal. That's maximum sound. Now, this is an AM amplitude modulated signal being shoved into an FM IF, so it probably shouldn't be paid attention to. The DC part should. That's what I think. So I would say that's maximum. Look at that, 10.7. Can we possibly improve this? Probably not. Probably cannot make any significant improvement, but we're going to give it a try. This isn't a really old radio. Nothing's happened to it. These coils should all be doing the same thing. Now, wait a second now. There's 5 transformers in there. You would guess these 2 are the FM because there's 3 in a row, and this would be the AM. That's a guess. Okay, so I'm gonna go on the idea that the lower 2 are. Good look in the manual. Let's fiddle with it. I like fiddling. Let's fiddle. So I'm getting the tool in. Okay, we're in one slug. I'm going to watch the scope here. See if it moves up and down. Oh. Now I tested one slug in here and the slug turned freely, but this one, there it goes. Well, clearly it went down. Oh, we're getting way up higher. Gotta be a little careful here. That's the FM, IF. Occasionally they are lined up perfectly, but other times in some radios they stagger them slightly. You stagger tune them and the result is a bigger bandwidth. You need a 200 kilohertz, something like that, bandwidth in these radios to work. I could be eliminating that. But we are in the starting mode here. Still on DC, I just changed the scale. Going higher. Going down. Okay, now I'm going to push the tool down to the lower part of the slug in this transformer. The lower slug, rather. Okay, I'm in the lower slug. Okay, we're just going for the highest voltage we can get out of this. Okay, it's not going up too much. Let's try the other transformer now. Okay, top slug. Not to worry about minimizing the volume. Bottom slug. Hope I've done the right thing. So that's maximize the IF, I believe. Now what we'll do is we'll vary the frequency of that. We'll watch the display and see that it isn't at its height at 10.7. Down. Right there. 10.697. Can't get any closer. Good. So that kind of, assuming using the single frequency technique is good for this receiver, that has eliminated the IF as the source of weakness in the radio's reception. Did I make a big difference there? I don't really think so. Sometimes when you're doing these alignment things, it's hard to tell in the end whether you actually generated an improvement. But we're going to listen to the radio. We'll see what's up. So I got to hook up an antenna, and let's do it. I got the antenna right here. The antenna is right here. So there are FM radio stations close to me. There are no... Oh, I got a story to tell you. I'm going to tell it to you. It's a quick story. Radio listening story. So a couple nights ago, I was watching TV and I said to myself, what am I doing? I'm going to go play with some of my big old radios. So started up my big Hammerlin radio. That's a great shortwave radio, but I decided I'd listen to AM broadcast with it. Pretty tough to do, you know, because of all the noises and that, but I gave it a shot anyway. Picked up a couple of stations out of the United States, of course. This is in the evening, maybe 9 o'clock in the evening. And, you know, so I'm listening, clear channel, 50 kilowatt stations. Picked up a couple. Then I stopped at one to listen to. It was a little hard to listen to, but I'm listening to it. And I realized they're talking about rain. They're talking about rain. That sounds like something's going on. So I listened for a little longer. They identified themselves as being Philadelphia, in the city of Philadelphia. WBZ, I think it was. I don't know if that's correct now. I'm just off the top of my head, WBZ. And I'm listening to them, and what they're talking about is the torrential rain, which is falling. And, of course, I didn't realize this. I didn't realize what was happening over there. So, in fact, I'm listening to them talk live about this disaster, very serious disaster that's gone on in the States. And there you go. That's a great radio listening thing, even though I didn't quite realize at the time what I was listening to. That's a good catch. Okay. Now, what am I doing? Okay, got the antenna on. I'm going to take this off because it's going to probably tremendously interfere with the radio's operation. Okay, first of all, volume up, do we hear a nice hiss? So volume is full, and I just hear some buzzy noise. There's no wonderful FM hiss here. Okay, back down. Back up. Full tilt. Well, doesn't seem to have helped any, does it? Why so dead? Huh. Why is it that dead? I wasn't quite expecting it to be that quiet. Is there something stupid I'm doing? Usually I can track down something stupid going on here. That's the AM. That's the FM. Should be some FM stations down towards the lower end of the band that are local. Yeah, that's right. I was about to say there are fairly local FM stations here. Ah. Well, I haven't done this radio any good, have I? Holy smokes. What is going on? Let's just reassure me. This is AM. Sure is. She doesn't want to work at all. Now, I have to admit, it's not the greatest FM antenna, but it's enough to make it work, that's for sure. Well, there are some more alignment issues, but wow, this is really dead. And it will receive a signal if you put one in with a signal generator. The signal probably is much higher than the regular radio station signal. I don't know. How do you know? How do you know? Well, that was a little disappointing. It would be interesting now. What I should do, we know the IF is centered on 10.7. I should run the sweeper again, see the result. I'm experimenting with that sweeper, and this is kind of what I have to do to get comfortable with it and to get some faith in it. I don't have too much faith right now because one generator with a single frequency says, hey, it was tuned to 10.7, and the other one says, hey, it's tuned to 10.5. I think 10.7 is true. Okay, sweep time. So the way I reached the conclusion that the IF was at 10.5 instead of 10.7 was through the use of a sweep and a marker amp. And it's pretty convincing to me, yet I have another way of doing it which is telling me something different. So let's see if we can replicate the first one. So I'm going to put on the sweeper here. I've got the wires connected, so the sweep output from here is heading into there. The other signal generator is still operating, but it's not connected to anything. It's just numbers of no meaning over there. Okay, here comes the sweeper. So it's sweeping past the tuning point of the radio here. Well, that's kind of wild. I tune this radio all over the place. Wait a minute. No, it isn't. We're punching the signal. That's right. We're putting in a roughly 10.7 swept signal into the IF. Okay, I've caught up with myself here. Scope. Where'd you go, man? So I've turned the scope so it's utilizing the sweep coming out of here. Is it just so dull we can't see it? I moved it down. There it is. So this horizontal sweep is coming from here now, and we should be seeing something on here. I'll go down. Sensitive. I hope to see the sweep shape. Why is that not happening? Take off this voltmeter in case it's causing problems. Scope alone could be insufficient signal. Radio's not tuned. Doesn't matter. Tuning doesn't matter. Frequency's not right on here. What's going on here? We're not getting the same thing there. So I have the volume. The volume is full. That's part of the picture here. I got the volume full, and it's telling me I'm using powerful signals when I'm actually not. Let's power it up. There we are. Now we see something. Okay. Now that doesn't look at all like what we want, though. It's a rather odd looking thing there. I'll give you the close-up view of the scope while we're doing this. So fooling around here. First thing is sweep width. Oh, see, the sweep width may have been too low. Doesn't that look nice? You know, as far as a scope trace goes. That looks lovely. Now I can change the sweep frequency. I should move that towards the middle of the display. Okay, and then I can reduce the sweep width, and we should make it bigger. Let me move it again using sweep frequency. Well, that just looks wonderful. Let me set it. I'm going to set it right on the. Actually, I'll use the scope adjustment. I'm going to set it so the peak is right on the center line. My camera go funny there. Now we can look at the symmetry of it by utilizing the graticules on the scope. And the symmetry is not 100%, but it's pretty close. It's a little wider on the left than the right. What frequency is that peak at? That's what we need to know. Last time I did this measurement, the suggestion was it was 10.5. But it really should be 10.7. So I'm going to attempt now to force in a... I'm going to stop for a second, rearrange my cameras for you. Hang on a second here. Okay, I've got an image of the scope in the top left of the picture now. Take the output from this signal generator. We're going to bash it right into the IF here. Didn't I use a capacitor last time? I'm doing something like this that caused the meter on my what I'm doing is I'm watching this meter. Well, that's knocking it right out. That's a little too much. Let's not knock it right out. Okay. The meter doing something funny. Nothing going on here. Still don't know what was happening there. Okay, nothing happened on the scope, or did it? The shape doesn't look right anymore. The shape looks tilted. Let me take this off again. Oh yeah, look at that. So go out here on this capacitor and reduce it even more. Oh, it's going to come right off. Okay. Now, maybe I reduce it to the point where it doesn't do anything. So I have a very low signal coming from here. I'm going to raise it up. And it's right. Can you see it? You can't see it. It's right there. See it going down the left side? I'm going to give it more juice from over here. Oh, that's a little too much. Okay, juice it up, knock it down. Now, you can see, you know what, I can full screen this at this point. I think that's more conducive to what we're doing here. So you see some fuzzy business on the right in here. Okay, so I'm going to move the fuzzy business right up onto the peak. by changing the frequency of the marker generator. Oh, wrong way. Okay, climbing up. So it's sitting right on the top of the mountain there. So the frequency on my frequency counter, it's not 10.7, it's 10.658. If I put it at 10.7, okay, yeah, it's just a wee bit off to the side. It's still pretty close to the top. It's certainly, and if I put it at 10.5, how did I ever get, it's just right off. It's right off. How did that ever happen? How did I ever get it at 10.5? So when you're hooking up test equipment to radios, you are affecting the radio. You're doing your best to not affect the radio, but sometimes it's so subtle. It's really tricky. It's tricky to become aware that that's what's happening. Well, I don't see that there's anything going on in the IF in this radio that would cause it to be quiet. I mean, it certainly looks good enough to me, for sure. So the question of why FM is weak, still hanging open here. Boy, oh boy. So what I'm going to do, I'm going to take these guys off of here. Still have the FM antenna connected. Here's something we can try here, a new way to use this equipment. So even hooking up the equipment to the antenna, that's not the normal antenna, can throw things off a little bit. Not much, but a little bit. What if I can get a strong enough FM signal to come out of these guys to get into this radio just through the antenna? Like if I just lay this kind of near the antenna connection, not too close to the radio, too close to the radio here. Set up there without somewhere just to try it. Okay, volume up on the radio. Don't know where the radio's tuned. Roughly 1 million. Put this up. So we're now putting out, there's 100 millions about here. Maximum signal strength. Does the radio hear it? Oh yeah, it does. Some interesting stuff on the oscilloscope there. Now this guy is not modulated in the AM modulation sense. The sweep is the FM modulation, and it's going at 60 cycles. You really shouldn't even hear it. We hear all kinds of stuff coming out of the radio. That's got to be where the 60 cycle sine wave is being messed up. It's the best way I can put it. Maybe overdriven. How can you overdrive it? I'm just on the antenna here. Thought this was low output. Okay, back on. Hot diggity dog. Okay. Wow, that's pretty strong. Well, volume was right up. That's why. Volume in a normal position, a lot more comfortable. And look up on the scope. Well, that's interesting. So we're firing in now a 100 megacycle signal into the antenna. We're doing it loosely coupled. The antenna is actually still connected up there. What is the antenna? It's that old TV rabbit ear thing I'm using there. Just the two arms are hooked up. So the effect you just are witnessing now, where you see, listen, you see it on scope. You wouldn't believe what I'm doing. I don't believe what I'm doing. I'm going to show you what I'm doing. I'm going to try to show you. That's looking down at the tripod the camera's on. And all I'm doing is standing here and doing this. So as far as I know, the tripod's just a chunk of metal giving my shot. I think what that says is there are, RF emanations everywhere in here. They're getting onto pieces of wire and other things that are not grounded or not connected to anything, re-radiating and causing a complex distribution of the signal here in my shop. One of the objects that's affecting this is the very large metal tripod I have here. When I put my hands on it, even though I'm touching a plastic part, I'm touching a plastic part, and it still has the effect. I must be influencing this machination of signals in here. Even though I have this kind of closely coupled, it must still affect it. I don't really know though. Okay, what have we found out now? We have found out the radio seems to be in pretty darn good shape IF-wise. Still, oh yeah, I was going to check for receiving. That's right, it doesn't receive stations. It receives this. Why are you not receiving stations? We don't know the relative strength of this whole arrangement here either. And this attenuator, what's it moving it around for? This is an attenuator. Huh. Just a few other things. Phase control still does exactly what it did. The marker amp is switched on here. Marker amp off, marker amp on, marker level up. I'm going to move this marker and see if we can get a pip to show up on the display here. There is actually something right there. Very, very small thing right there. And is that by some chance this? So I'm going to swing this guy out of here. Oh, look at that. How come that had an effect? Okay, so this guy's out of the picture now. He can't be doing anything. Marker. Just moving my hand around in here. Again, it's because of the... I think it's just because of the way I've done this. Okay, holding my hand still while I do this. So I'm watching very carefully. And there is something going on right there, but it's very hard to see. I'm sure you can't see it on... Oh, what was that? Oh, look at that. Okay, so we're climbing up right on the top. Whoop. Right on the top. There. Okay, so I've done something. What have I done? So we look at now, realizing I have not calibrated the scale on this. It is saying 94 or... think about this. Yeah, that's interesting. I need to get another. I need to get another. Exactly. Okay. We got lots and lots of stuff on the screen here to look at. So, on the SDR, you can see the sweep quite clearly. If you can't read the numbers, it's going from 98.2 to 98 point, I would say, 9. Almost a megahertz wide, centered on 98.6 or something like that. Now what I'm going to do, I'm going to compare what we're seeing on the SDR with what can be heard on this radio. I'm going to tune the radio and try to pick up the fringes of the sweep. So right now the radio is set below the sweep, 96 megahertz. Will just go up and oh, we already detected it, did we? Why so quiet? What's happening there? 96. What's set at 96? Maybe it's this. I don't know. Okay, let's go up to 100 anyway. Something funny going on there. That's why you do these things. Now that's the sweep. There's the edge of it, 97.9. So if we look at the SDR, well, the SDR suggests 98.2 or so. Of course, there's a bandwidth here in this radio, and although it's tuned to 97, the bandwidth, the leading edge of the bandwidth, if you like, is probably getting up into the sweeper. That's probably what's happening. FM radios have a wide bandwidth. Go up to the other end of it, sweep, 99.2 on here, and on the SDR it's 99. It's under 99. So I think that's what's happening. I think we're sliding this thing like this radio like this because of the bandwidth on it. So the two things are jiving. That's what I'm trying to double checking. I don't get caught in the middle of nonsense here. Now, so that's a 1 megahertz sweep. So on the oscilloscope, I believe what this means is it's 1 megahertz from the left to the right. It's 1 megahertz roughly from here to here. I'm going to move this. Well, I can tune the radio, or I'm going to tune the radio. So tuning the radio should move the sweep more towards the middle. Funny things happening, eh? Funny shapes. What's that thing? What's that thing coming up the left side there? Okay, so as far as the radio is concerned, I believe the signal is tuned in perfectly. But the doubts with everything. Let me move the marker frequency around here. Oh, oh, I can see it on the SDR. I'm looking at the scope. Meanwhile, it's totally visible on the SDR. Oh, right on by. Well, this is really helpful. Really, really helpful. How would this be helpful? Well, interestingly enough, you can see that the scope and the SDR are kind of agreeing. I'm watching the scope. I'll put the, I'm supposed to call that a pip, but that's no pip. Where'd it go? Oh my gosh, it's very hard to move precisely here. If I can get it there. Okay, that's more or less on the top, and you can see the pip, beautiful pip on the SDR is right in the middle. Great. Now, what good is all this? I think it's better to work to the SDR. Except the SDR will never show the actual response curve because there's too much going on in the SDR processing to that rocking boat there. Let's see if I can stop the rocking boat again. Let's just try that. So there's quite a number of things in here. AGC. What else is in here? AGC. So the use AGC is checked off, but it's grayed out. That could be, let's just go down here and see that there isn't another AGC type thing going on. No, I don't see anything, so I'm going to stop it. So there's another, well, this is turned off, RTL, AGC is turned off. Tuner AGC is also off. Why do I turn these on? Does anything happen? I played around with this stuff before. Never really got it to make any difference to anything. This is still grayed out here. Okay, well, I'm going to put the AGC back to where it was, simply because I want to be consistent. Doesn't seem to do anything anyway. RF gain control. Never noticed that. Back we go. So it looks to me like what happened just now is this level here out at the side was up much higher with the AGC on. Why that is, I don't know. Okay, so we got a great display here. There's some other things happening in there, little pips. I don't know what those are or where they're coming from. Display is about a megahertz. About a megahertz. I have a crystal here I could put in. And what would that do? Shouldn't really do anything. I'm going to stick it in there and see what happens. Yeah. Experimenting is the name of the game here. So lots happened while I was handling this because it's very sensitive. I don't think anything happened otherwise. Not that I noticed. So what can we do with this now? Oh, that's right. I was going to get another... yeah, okay. I know what I need to do. I'm going to go do it. Okay, I brought in another signal, frequency counter rather. There it is. One I don't usually have in my shop here. This is down in my radio room. So this guy has a range up to, I think, 100 megahertz. And it may not be visible on the camera the way things are. It's another reason why I don't have it in here, but I can certainly read it. Here's the leads from it. We're going to try to read the marker amp frequency. Now, I believe there's many frequencies coming out of this. There's the primary frequency, and then there's some harmonics that are coming out. So I don't know what this thing is going to count. I just kind of killed off the scope there. Ooh, what happened? I must have hooked up the wrong thing. That's what happened there. Let's try the right thing this time. Notice the look of the scope has changed. Looks like the marker is much stronger than the I don't get it. This shouldn't be changing the frequency. It's supposed to change the amplitude. Oh, that's how you do it. Okay, let's count this stuff. One of the approaches I have here with learning something new is to try to make as many mistakes as possible, and the way I do that is being a little lackadaisical in what I'm doing. And I try to encounter things that I would never think my way to, right? I don't know they're there to be encountered, so things look a little messy. That's good. But what do we got here? So now, can I get this on camera? It's just not going to want to show you the numbers there because of the way that's a screen. It's a backlit screen. So what it says is 32.837 megahertz. What I can show you is the scale here. So it says 93, and right above it 31, almost 32. 32? 32. So I guess probably the fundamental is 32, and it's coming out quite strong. And then there are some, maybe the third harmonic would be 96, and it's just not coming out so strong as to be counted. And the fact is I can use the counter to figure out where I am on this outside dial. But that's my phone, isn't it? That was my phone. The outside dial is not necessarily directly calibrated to the inside dial, or is it? Think about it now. These things have to operate in a ratio of 3. It has to be. So if I read 32, if I read 32.834, I know if I multiply that by 3, that's probably the frequency that's causing the pip on the SDR. Let's try that. Get my calculator out. I'm not smart enough to do this. So we say 32.835. 32.835 times 3 equals 98.5. Okay, now we look at the SDR. Look at that. 98.5, and there it is. Great on the money. So what this means, this is good news for me. This means, this is really good news. I have other frequency counters. They don't go up to 90, but they'll certainly count that. So I should be able to use my counters that are in here already on this. Wait a minute. I don't need this. What am I saying? I'll use the counters I have right on the output from here. So I can know the marker frequency with precision. Well, then if I want the marker frequency, let's try this out. If I want the marker frequency, where'd my super calculator go? Here it is. I want the marker frequency to be at 10.7. So I go 10.77. There we are. Divide by 3. Wow, it doesn't go down that low. 3, it's got to be... No, I can put it 10.7. No, I can't. This only goes down to 19. That's right. I was trying to shove a 10.7 in through here. Well, let's just see where it goes. 24. This is calibrated fairly well. I've got it on 20, and it's right around 20. Yeah, so I don't think we're going to be lucky. Let's see how far up we can go. We can go up to... There's 43. Yep, it's counting it. 45. Here's right at the top 60. It's counting 4. Let's go down a little bit. Can I get it to count 10.7 there? I can. 10.7. 10.7. It says 10.7 here. You'll have to trust me on it. It just went to 11. Well, what? 10.9. Is it my hand doing that? I don't have the metal case on this generator here. Okay, well, it's 10.6. It's jumping around 10.7. It's going around up and down. Could be, all these harmonics that sometimes they're adding up, sometimes they're subtracting. Maybe that's throwing the counter off a little bit. We're right around 10.7. Well, if we are, we'll find it on the SDR here. What do I think now? What am I doing? Why am I doing this? Who am I and why am I here? So let's go see. Yeah, 10.7. I've got to find that here. What's going on? Lost my mind here. I lost my mind. So we were seeing it up here because it was 32 and a multiple will put it right into the band. What I'm trying to do now is dumb. This isn't going to work. This isn't going to work. So let's put it back to where it influences the SDR again. I'm looking at the SDR now. Here it comes. Here it comes. Whoop, right by. Okay, roughly in the middle. The SDR display. 32.9 here again. Right around 32 on there. Excellent. So the SDR is not looking at the radio at all. The SDR, what is the SDR looking at? The SDR pickup coil. I just realized I never moved it. The SDR pickup coil is hanging. Wait, that yellow thing swinging down there. That's the pickup coil. Get a little closer to the radio. Doesn't seem to make much difference. Okay, where am I at now? Where am I at here? So I have the sweep sweeping around the frequency that the radio is tuned to. The sweep is getting in just through being close to the antenna lead. Sweep goes in, sounds like this. Tune the radio just a wee bit. There's the pip. You can hear it. You can hear it, eh? So now I have the radio tuned. So the what if I change this? Oh my gosh, what's going on there? Pretty messy stuff. So generally speaking, messy stuff means too much signal going into the radio. I can't do much to reduce it. It's just here too. There can easily be FM signals just coming right out of the back of this generator. You see how the antenna is dragged over the generator. You got me. Okay, just experimenting, having fun, everything's messy, that's good. Then what I should try is I should try counting this output with a regular shop counter. I decided to keep the video running because as I do things, just moving around, all kinds of stuff is happening. So, okay, I'm going to put this on my other signal counter up here. Can you see that from there? Cannot because of the... There it is. That guy. This guy here. Okay, this is the marker. Here, input attenuator on. 2959. 20 says there we are. 32.9, same number. I've got the attenuator on and it's giving a nice reading. The oscilloscope, what has happened to the oscilloscope? It went flying. And I didn't notice it happen. Let's just take this off now. What the heck is going on here? Look at this. Oh my gosh. So I'd say in a regular, say, factory shop, all this stuff is set up. They've figured all this stuff out. They've overcome every little problem. And nobody changes anything as they work their way through whatever it is they're working on. But in my shop, every time I got a new device, everything's kind of mixed up differently. Just doesn't look anything like what it looked like when I started the scope. But on the SDR, everything looks normal still. Except the SDR is not showing us anything to do with the radio, it's showing us what we're presenting to the radio. Silent there as I'm trying to figure out what I think I'm in a great position here now, but what to do. So we have to pay attention to the output of the radio for sure in order to do the next alignment steps, which I'm afraid are fooling around with the FM receiver, the stuff in the box itself. The box that's down here. The box, there it is. Through those holes are a bunch of adjustments. Always anxious about doing any of that, and that's one of the reasons why I'm trying to get my equipment as under control as possible. So A, I have the horsepower, and B, I've got the brain power to not mess this up. Yeah, I'm going to stop for a little bit now. I may post this as it is right now. I don't know. I don't know what to do. What should I do? I don't know. Don't know what to do. Okay, I know what I can try as a last thing. So the very first alignment step with this receiver is to make sure the pointer is pointing in the right place. And they use 108 megahertz to do it. Let's see if I can produce 108 megahertz and know for sure I've done it. I'm going to come a little lower up the camera here. So down here where the FM pointer is, on the back plate there are some holes drilled. A little one there, a little one there, a little one there. These are almost certainly alignment marks. And what it's suggesting you do is you tune the radio so it lines up with that mark, but I can't get there. Yeah, and to make that pointer go further, it's like it has, oh, what happened there? How did it suddenly go further? It just seemed to force the mechanism a little further. I'm not sure what happened there. Is it just like something sticking it? Okay, well, it's almost completely lined up now. It's really quite close. In fact, if I get in here, parallax, it's just a wee bit off. There's no particular adjustments to the pointer itself. The adjustment is made by loosening off this drive wheel. I'm not anxious to do that, that's for sure. Okay, so we think that's around 108. So I'm going to try to set the, well, I'm just going to turn up the frequency over here to 108. Wait a minute, think, man, think. Maybe I need this to be at 108 also. Let's put the SDR on 108. 108. Okay, so the red line, whoops, that was stupid. The red line was right at the top of the FM band, 108. There's something there. I wonder what that is. Something there on the SDR. Okay, so first we'll try to get the sweep up there in that range. Up, 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 not down. Up, 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 watching. There it comes. The sweep is roughly centered on 108. Now the marker, if I do it by calculation, it'd be 108. Where'd my power calculator go? 108 divided by 3. 36 exactly. So if I can get 36 to show on the frequency counter, 36. Oh, wrong counter. Can you get 36 there? I'm going the wrong way. Wow, didn't that do something? So if I get right on 36, that's 36. And when you look at the SDR, it's right in the middle. So 36 gives you 108. The pip is sitting on 108. And the radio is tuned to 108. The sweep is in the center. It's equal on either side of 108. So I think the radio is good. I think for some reason, up until now, you have not been able to push the pointer over far enough. I don't think any kind of realignment thing happened there. I think it was just stalling out before getting all the way. Well, that's good. Okay, okay. That settles the problem of is the pointer in the right place. Good. Okay, now I think that's it for today. I think I'm done now. Lots here to think about during the day. Of course, I don't think about it during the day, but I will. And tomorrow, I don't know what I'll do in here. We've got to get the FM radio working. Could still be an alignment issue. Could be a component issue. Don't know. Only way to know it's not an alignment issue is to do the alignment activities and see what happens. So we're going to have to poke around with it somewhat tomorrow, right in that tuner. Okay, thanks a lot for watching, and have a great day.